All right, so we're on 3.1 variations. Raise your hand if you guys know how to multiply and divide. Yes, that's all you need to be able to do today is can you multiply and divide? If you can, then awesome sauce. We are going to do wonderful. Okay, so first we're going to fill in with some vocabulary word. Back in Algebra 1, you guys learned about direct variation. Direct variation is just another way of saying a linear equation that goes through the origin that has a y-intercept of 0. That's what your direct variation was. You either had a positive direct variation or a negative direct variation. Okay, that's in Algebra 1. We also talked about it a little bit when we were getting ready for the TSIA, if y'all remember vaguely. Now, we're on inverse variation, okay? Inverse variation is when we're in this format. So we're going to, the word for this blank is inverse variation. Okay? Inverse variation means that there's a different type of growth that is happening with our function, okay? When we have inverse variation, it looks like x times y equals k. That's how we find our k. But the function that we're using is y equals some number divided by our independent variable, our x. All right. Next vocabulary word is when one quantity varies with respect to two or more quantities. The key thing here is with respect. So we've already used inverse variation. This is called a joint variation. So with respect, it's called a joint variation. Okay. And then when it says when one quantity varies directly with two or more quantities, so keyword is directly, this is called a combined variation. Essentially, what these two things are meaning is that there's multiple factors at play on how the function is changing over time. And last but not least is our constant of variation. Okay, your constant of variation is the product of two variables in an inverse variation. Typically, when you're talking about a constant of variation, it's called your k. And if you look right here, it tells us how we're going to find that k. Okay, so far, questions about the vocabulary? All right, let's keep it trucking. So here is our process of finding our how to determine our variation. Let me get my laser point. So how does the first thing you're gonna look at is what are your x values doing? Are your x values increasing or are they decreasing? That's the first thing you're gonna determine. If they are increasing, then you're gonna next ask yourself, what are your y values doing? Are they increasing or are they decreasing? Because we're focusing on inverse variation for right now. We're going to look and say, okay, well, if it's decreasing, then it's going to lead me here. It's going to lead me to an inverse variation, okay? If it was increasing, it's going to lead me to a direct variation. A direct variation is what I reminded you guys is what you guys did in Algebra 1, and that's because it's a form of a linear. So when you have this y equals k divided by x, that means that the function that best models it is y equals k times x, which is just a linear model, right? You have a slope with a y-intercept of 0. Okay. When we follow the path of decrease and then increase, or if we follow the path of increase, then decrease, that's going to lead us to an inverse variation, okay, which is what we're talking about here today. Inverse variation is where we have our x times y equals k. And this equation that it comes from is y equals k divided by x. Notice that for inverse variations, your independent variable is in the denominator. So it's not a linear function. It's an inverse function, which we're going to learn in 3.2 is called something else. All right. Once you have decided which one you're you're going to check to make sure that the k value is the same for all given data. And if they are the same, then yes, it's direct variation. If they're not all the same, then no, it's going to be neither. All right. So let's dive into our little calculations here. Okay. Do the data in the table represent a direct variation or inverse variation or neither? So when we look right here, step one is you're going to determine what are your x's doing? Are your x values increasing or decreasing? So when we look here, what are our x values doing? They're increasing. Agreed? Okay. What are your y values? Increasing or decreasing? They are decreasing. Okay. Based on our chart, if my x's are increasing and my y's are decreasing, what path is that leading me down? So we have increase, and then we have decrease. So that leads us down to the inverse variation. Okay. Which means that we're going to check to see if it's an inverse variation by taking our x's times our y's and see if they have the same k value. Okay. So we're going to be doing, as right now, we believe that this is a, where's my pen? Inverse. Okay. So we think it's inverse variation, which means now we're going to check to see if our k value equals your y times your x, and if it's the same for all of them. So you're doing literally multiply. 20 times 1, what does that give us? 20. 2 times 10 gives us? 4 times 5 gives us? And 5 times 4 gives us? Are they all the same? Yes, so therefore it is inverse operations. So yes, it is an inverse operation, check, with the k value of 20, which means that the equation that would best model this would be y equals 20 divided by x. Was that terrible? All right, we're going to try one more together, and then you guys are going to do one on your own. Cool? Okay, so example number 2. Step 1 is to determine what are your x's doing. So what are our x's doing? They are increasing. Okay, step 2 is to determine what are your y's doing. What are our y's doing? They're also increasing. So if I have an increase and an increase, what is that leading me to? It leads us to direct variation. Okay, so we're going to be checking for direct variation. When we're checking for direct variation, our k is what? Our k is y divided by x. So we need to check to see if we divide all y's by the x, do they produce the same answer? Okay, so we're doing 10 divided by 5, and that's going to give us 2. What about 20 divided by 10? 2. What about 30 divided by 15? What about 40 divided by 20? Are they all 2? Yes. So is it a direct variation? Yes, it's a direct variation with a k value of 2. So our k value equals 2, which means that our function that would model this would be y equals 2 times x. Do we see how we pulled all that information? Guess whose turn it is to pull the information? It is yours. So example 3, you're going to do on your own and then check with someone at your table. Are we ready to try? Okay. So on here, first thing you ask yourself is what? About what? Your x. And what are your x's doing? They're increasing. And then you check your y's. And what are your y's doing? Decreasing. So if I have an increase in the x, a decrease in the y, what path does that lead me down? Inverse. My pen is lagging and it's making me write like a crazy person. All right, so because it's inverse variation, that means I'm checking to see if the k is the same. How? By multiplying your x times your y times your x. Does it matter which way? No. So you have 1 times 12. What is that? 12. 3 times 4. 4 times 3, 6 times 2. And as long as all of them are 12, then this is 12. K equals 12. And therefore, this is inverse variation. So our function model would be y equals 12 over x. Ta-da! Yes? Okay, so this is the foundation. You're not going to be analyzing tables. The foundation of inverse variation is actually word problems. Okay? Real world scenarios. But don't worry. You just have to read and then make your own data. You got this. You got this. It's cool. Don't worry. I believe in you. Okay? And so if you can do this, you're good. You just have to have the understanding of what you're looking for. Okay? So what we've talked about here is that for inverse variation, when we are writing the variation equation, to solve problems involving inverse variation, you need to solve for the constant of variation, your k first. So the first thing we're going to do is solve for k, right? The second thing we're going to do is write our equation. And then the third thing we're going to do is solve the equation. Make sense? Okay, we're going to solve. We're going to find the k, write the equation, and then solve. Find the k, write the equation, then solve. Got it? Because it's inverse variation, the equation that we're going to be working with is y equals k divided by x. Okay, that's the only one we're working with. Remember, direct variation is the thing of Algebra 1. Okay? Capiche? Ready to dive in? Let's do an example together, okay? So example 4, it says the time t that is necessary to complete a task varies inversely as the number of people p working. If it takes 4 hours for 12 people to paint the exterior of a house, how long does it take for 3 people to do the same job? Okay. So highlighting important things here. Our variables are t and p. Those are our two variables, right? And we know that they vary how? Inversely. Okay. These are the most important things because they vary inversely. We know that in order to find our k, it's going to equal our independent variable times our dependent variable. Does that make sense? It equals t times p. Okay. Still with me? What given information did they give us for t and p? Well, they gave us a time of 4 requires how many people? 12. So they gave us a t and p used to find our k. Does that make sense? So we have t equals 4 and we have p equals 12. Can I find my k? Can I do step 1? Yeah. So step 1, your k. Your k equals your time times 12. So therefore k equals 48. So we have found our k. Step 2 is to write your equation. Because this is inversely related, that means that our equation equals y divided by our k. And what is our k? 48. So our equation would be y equals 48 over x. Step 3 is you're going to solve for what it's asking you. What is it asking us? How long would it take for 3 people? So therefore, we know our p. And our p equals 12. So in terms of this problem, instead of y's and x's, we have p equals 48 over t. Does that make sense? Because t is our independent and p is our dependent. So this is what, for this problem, we would be working with. So I'm going to plug in p. So we get 12 equals 48 divided by t. How do you solve this? If I set it up like this, does that ring a bell? We cross multiply and divide. We're going to cross multiply and divide. So when we cross multiply, we get 48, and we're going to divide it by 12. And what does that give us? 4? Yes. So if we have 4 people if we have 12 people working, how long is it going to take? And 3 people? Oh, guys, I plug in 12, 3, 12. And no one said nothing to me. Y'all just let me do whatever I want. Why? Thank you for watching me be a failure. I highlighted 3, I wrote 3, and no one said anything to me until I got to the end and I had to solve my own problem and realized that this was making absolutely no sense. Embarrassing. I don't even know why I wrote 12. We already knew how long it took 12 people. I'm like, why'd I get 4 again? Like I was trying to figure it out because we've already done it. All right. Do you understand the 3 steps that we went through correctly? Make sure you have what you're solving for correct. If not, let me know. So step 1, we found our K. Step 2, we wrote our equation. Step 3, we solved for what was unknown. Okay? Yay? All right, guess who started this? Here is yours. Okay? I want you to try this completely by yourself and then check with the peer when you're done. So you're going to go completely by yourself and then check with the peer when you're done. All right. So on this one, you had your variables. So you had your time and your P. You had your given information, which is 5 hours and 7 min. So therefore, time is our independent, P is our dependent, and therefore we have our initial T and our initial P. Okay, we know that this is inversely variation. So we're going to start with our K. So our K equals, in this case, our T times our P. Agree? So K equals 5 times, our people is 7 min. So our K should have been 35. How did we do? Okay, after you find your K, set up your equation. So your equation for inverse variation for this particular problem is P equals 35 divided by your T. Still with me? Third thing is to solve your problem. It wants to know if you have 10 min, how long will it take? Well, 10 equals 35 divided by T. This is a simple proportion. We cross multiply and divide, and we're left with, there we go, 35 divided by 10, which is going to give us 3.5 hours. The more men helping build cuts down our time. Shocker. Who would have thunk it? Okay. Simple variations, and go again. Live in. All right, guys, what'd y'all get? Does it make sense that it takes less time if you drive faster? Yeah. So what was your K value? Your K value was what? 300. Did we get 300 for our K? Okay. And then after you did your K, therefore your equation came out to be, there you go, R equals 300 divided by your T, correct? And then if you are driving 60, 60 equals 300 divided by T, which gave you T equals 5 hours. Yay? Do we see inverse? How we feeling? We're not like totally cooked? All right. So I'm going to have y'all do the last 2, and then we're going to check to make sure we're all good. So you're going to do 7 and 8. We're going to check, and then we're going to move on. So on the first one, let's talk about her. What is our K and how? 61.32. So your K in this problem would equal your, oh, that's an ugly K. I couldn't even tell you. I couldn't even commit to that. That was a K. That one's better. So you found it by doing 42 times 146, right? So you got your K equals 61 point what? 32. Step 2 is to write your equation. So it says that the cost of each item bought is inversely proportional to the number of items when spending a fixed number. Okay. So your cost, so your C equals your, I wrote that backwards. What variable? I'm just going to use X's and Y's because I can't do it any other way. It's kind of weird how it's given me. So we're going to do X's and Y's. Y equals our K, which was 61.32 divided by our X. So we're solving for our items. So we know the items when the cost is 216. We're looking for items when the cost is 216. So we have 216 equals 61.32 divided by X. Logically, if they increase the cost of something, you're gonna be able to only buy less items, right? So in the end, instead of being able to buy 42 items, I can now only buy, did y'all get 28 items? Inflation. Okay. Yes. If we didn't get it, do we see where we may have made a mistake or we're good?